This video is going to cover implicit differentiation. What we're going to do in this video using implicit differentiation is we're going to try to find the slope when we have an equation where y is not isolated. And the reason this is important is not all relationships give y as a function of x. Not all equations are solved for y. For example, consider the circle x squared plus y squared equals 25. This is actually not a function, and so this equation is not solved for y, but we might still want to know what the slope of the tangent line is. How can we find this slope? Well, one way we could do this problem is we could take that equation, solve it for y, and then find the derivative. However, if we take that equation and we solve it for y, because there's a y squared, we're going to end up getting a plus or minus square root of 25 minus x squared. And we could figure out whether we're on the top half of the circle with the plus or the bottom half of the circle with the minus, and then take the derivative. But our implicit equation, our equation that is not solved for y, is a lot simpler. So again, our equation that is solved for y, this is our explicit equation. This is kind of complicated, but the implicit equation, the equation that is not solved for y, is simpler. So what we're going to do is we're going to take advantage of the chain rule to find our derivative implicitly without solving for y. So I'm going to take the derivative of both sides of this equation. And I'm taking the derivative with respect to x. My goal is to find the slope of the tangent line, or dy dx. All right, so derivative of x squared, well, that's just 2x. Plus, now to take the derivative of y squared, we are going to treat y as a function of x. Y is our output variable. And so we're going to have to use the chain rule. We have some function y squared. So when we take the derivative, we're going to get 2 times y. But then we have to multiply by the derivative of the inside. We have to multiply by the derivative of y, which is dy dx. So the derivative of y squared is 2y times dy dx. The 2y is my outside derivative. The dy dx is my inside derivative. And then the derivative of 25, well, that's just a constant, so that has a derivative of 0. And so what we can do is we can actually take this equation and solve it for dy dx. I would do that by minusing the 2x. So 2y dy dx equals negative 2x. And then we can divide both sides by 2y. So dy dx equals negative 2x over 2y. And I would cancel those 2's out. And what I have right now is an implicit equation for the derivative. The slope of the tangent line is negative x over y. So back to my picture, if I am at the point x equals 3, y equals 4, that's a point on this circle, the slope using my formula should be negative x over y, or at this point, negative 3/4. And that's exactly what I see on the picture. My slope is down 3 over 4. And I could use my implicit formula to find the slope of the tangent line at any point on this circle. All right, so let's just do a bunch of other examples to illustrate how this process works. Let's see if we can find dy dx for 3x squared y cubed plus 2x minus y equals sine of y. So this equation is not solved for y. It's an implicit equation. And in this case, I couldn't even solve for y if I wanted to. So we're going to have to find the derivative implicitly. So what I'm going to do is take the derivative of both sides of the equation one term at a time. And I'm going to start with that first term, 3x squared y to the third. That is a product, so I'm going to have to use the product rule. I'm going to say that my first part of the product, the f, is 3x squared. And the second part of the product, the g, is the y cubed. So f prime should be 6x. And to find the g prime, now this is where I use my chain rule. Y is actually a function of x. So we have our function cubed. I bring down the 3, I get 3y squared. But then I have to multiply by the derivative of the inside. The derivative of y, I don't know what that is, so I'll just write dy dx. So again, the 3y squared is my outside derivative. The dy dx is my inside derivative. And this is the chain rule. Notice what's happening with implicit differentiation is anytime that you're taking a derivative of a y, you're going to multiply by dy dx. Okay, so applying my product rule, I'm going to take f prime times g, so 6x y to the third, plus g prime times f. So g prime times f, 3 times 3 gives me a 9. There's an x squared, a y squared, and then that dy dx. And this is the derivative of that first term. Okay, so let me erase, give myself some more room. So here's the derivative. I've just done the first term only. So moving on to the 2x, derivative of 2x is just 2, so plus 2. And then we've got a minus y. The derivative of minus y should be minus 1 dy dx, or just minus dy dx. Derivative of y is dy dx. And then I've got my equal sign, and sine of y has a derivative that's cosine of y, but y is a function of x, so I have to multiply by dy dx. So I have taken my derivative implicitly one term at a time, using my chain rule and my product rule. Now I've got to solve this for dy dx. And usually I actually use the notation y prime instead of dy dx. It doesn't matter, but I just find it easier to write since there's so much writing here. So all I've done right now is I've just changed these dy dx's to y prime. So I just changed the notation just to make it a little bit easier for me to write things down and keep track of things. All right, so what I want to do is I want everything with y prime, that's what I'm solving for, on one side of the equation, and everything without y prime on the other side. So I've decided to put all the y primes on the right-hand side. So I am going to take this 9x squared y prime and subtract it to move it over. And then I'm going to take my minus y prime, add it to both sides to move it over. So now I'm just left with 6xy to the third plus 2 equals cosine y prime minus 9x squared y prime plus y prime. Finally, to solve this equation, I'm trying to solve for y prime. On the right-hand side, every term has a y prime in it, so I'm going to factor that y prime out. And if I factor the y prime out, I'm left with cosine y minus 9x squared y squared, and then plus 1. And then finally, we can divide both sides by that cosine y minus 9x squared y squared plus 1. And there's my final answer. It looks pretty complicated, but I have an implicit expression for my derivative. Y prime is 6xy to the third plus 2 all over cosine y minus 9x squared y squared plus 1. All right, let's do another example. Write the equation of the line tangent to 2x squared minus 4y to the third equals 2x divided by y squared at the point 2, 1. If I want to find the equation of a tangent line, I need to find the slope. To find the slope of the tangent line, I'm going to have to find the derivative. So I'm going to take the derivative implicitly, one term at a time. So I'm going to start with the 2x squared. Derivative of 2x squared is 4x. Then we've got this minus 4y to the third. So I brought down the 3. That gives me 12y squared. But I have to multiply by y prime. There's my chain rule. All right, on the right-hand side, I have 2x divided by y squared. I'm going to use the quotient rule for that. So the top, the f is 2x. The bottom, the g is y squared. Derivative of 2x is 2. Derivative of y squared, I brought down the 2, I got 2y. But again, I have to multiply by y prime. Y is a function of x, so that's my chain rule. Using my quotient rule, f prime times g minus g prime times f all over g squared. So let's see, f prime times g, 2y squared, minus g prime times f, that's going to be 4xy times y prime, all over g squared, so y squared squared. All right, so this is 4x minus 12y squared times y prime equals 2y squared minus 4xy y prime divided by y to the fourth. I need to solve this for y prime, and because I have a fraction in this equation, I'm going to clear the fraction by just multiplying both sides, everything in this equation, by that denominator of y to the fourth. And that's going to allow me to clear the fraction. So on the, let's see, left-hand side, multiplying by y to the fourth, I'm going to get 4xy to the fourth minus 12y to the sixth y prime. And then when I multiply by y to the fourth on the right-hand side, those y to the fourth cancel out, and I'm just left with 2y squared minus 4xy y prime. Now I'm solving for y prime, so I want everything with y prime on one side of the equation and everything without y prime on the other side. So this time I'm going to put the y primes on the left. So I'm going to keep this minus 12y to the 6y prime on the left, and I'm going to take the minus 4xy y prime and add it to move it to the left. And then I want everything without y prime on the right. So I'm going to keep the 2y squared on the right, and then I'll minus the 4xy to the fourth. All right, almost done. To finish, I'm going to factor out the y prime on the left-hand side. I'm left with negative 12y to the 6th plus 4xy. I can divide by that. And y prime is 2y squared minus 4xy to the fourth all over that negative 12y to the 6th plus 4xy. All right, so there's my derivative. Let's see, we're not done with this problem though. We are asked to write the equation of the tangent line. So the derivative is going to give me the slope of my tangent line. I want to find my tangent line at the point 2, 1. So I'm going to take 2 and plug that in for x. Then I'm going to take 1 and plug that in for the y's. All right, this simplifies all the way down to 3 over 2. And so that is the slope of my tangent line. So slope of my tangent line is 3 over 2. And then, oh, we also know our point of tangency. It's the point 2, 1. So my equation is y minus 1 equals 3 over 2 times x minus 2. Finally, I want to show you how we can use implicit differentiation to find a second derivative. So let's see if we can find the second derivative, d squared y dx squared, for 3x squared plus xy squared equals 10. The first thing I'm going to do is find my first derivative. So I'm going to take the derivative one term at a time. The derivative of 3x squared is 6x. For the term xy squared, we're going to have to use the product rule. So I'm going to say my first part of my product, my f, is x. The second part of my product, the g, is y squared. Derivative of x is 1. Derivative of y squared is 2y times y prime. Using my product rule, I have to take f prime times g, so 1 times y squared, plus g prime times f. So x times 2y, y prime. And then equals, and derivative of 10 is 0. Now I'm going to go ahead and solve this for y prime. So I took the terms without y prime and moved them to the right-hand side. So I minus the 6x minus the y squared. And then to solve for y prime, I just have to divide by 2xy. So there's my expression for y prime. Now to find my second derivative, I'm going to take the derivative of that answer. So I have to take the derivative of negative 6x minus y squared divided by 2xy. We're going to have to use the quotient rule. So my numerator, the top, the f, is negative 6x minus y squared. The g, bottom, 2xy. So f prime, derivative of negative 6x is negative 6. And then we've got minus 2y, y prime. To find my g prime, we're going to have to use a product rule. I'm going to say that the first part of my product is 2x, and the second part is y. Derivative of 2x is 2, derivative of y is y prime. So f prime times g. So let's see, that's 2 times y plus g prime times f, 2x times y prime. All right, plugging this into my quotient rule, a little complicated, but here we go. We've got our f prime times g minus g prime times f all over g squared. Now I'm going to simplify this. So I'm going to do a bunch of multiplying. I'm going to take my f prime times g. So I'm going to take 2xy, and I'm going to distribute that to the minus 6 minus 2yy prime. So that's how I got this negative 12xy minus 4xy squared y prime. Then I'm going to have to FOIL out my g prime times f. And then I'm also going to keep this minus sign and put some parentheses there so I don't forget that I'm actually subtracting that. So first gave me the negative 12xy, outer minus 2y to the third, inner minus 12x squared y prime, and last minus 2xy squared y prime. And the denominator is just 4x squared y squared. All right, so let's distribute that negative sign and combine like terms. So I distributed the negative sign. That actually took all of these terms inside the parentheses and made them positive. And then I'm going to try to combine my like terms, and, well, the 12xy's cancel out, so that's nice. And then let's see, 4xy squared y prime plus 2xy squared y prime. I can combine that to get a negative 2xy squared y prime. And then we still have this 2y cubed plus 12x squared y prime over 4x squared y squared. All right, so we multiplied everything out, combined like terms. We're not done, unfortunately. So finally, when you're finding a second derivative, you find your first derivative, you take the derivative of that. There's going to be an extra step there. We really want our final answer to be in terms of x and y only. So what we're going to do is we're going to get rid of these y primes because we actually know what y prime is. We computed that earlier. So I'm going to replace both of those y primes with my negative 6x minus y squared over 2xy. All right, so I replaced both of my y primes with that derivative. And then I'm going to see if I can do some simplifying here. First term, we can cancel the 2, the x, one of the y's out. Second term, we can cancel the 2 with the 12, one of the x's. So I'm just left with negative y times negative 6x minus y squared. And then I've got plus 2y cubed. And then this last term in the numerator, after our canceling, we've got a 6x. And then we still have this divide by y times negative 6x minus y squared. And this is all over 4x squared y squared. All right, let's distribute. So I'm going to distribute in the numerator, distribute the negative y. That gives me 6xy plus y cubed. And then I still have this 2y cubed. And then I'm going to distribute my 6x divided by y. That's going to be negative 36x squared over y. And then minus 6xy, because one of those y's cancel out, so minus 6xy. And this is still all over 4x squared, y squared. All right, I think we should do one more thing. This is a complex fraction. So I am going to simplify my complex fraction. I want to get rid of this y, this little fraction within the fraction. Before we do that, though, it does look like we have some like terms, so we might as well combine them. The 6xy minus 6xy, those add up to 0. Y cubed plus 2y cubed is 3y cubed. Okay, so 3y cubed minus 36x squared over y, all over 4x squared y squared. So finally, so this is no longer a complex fraction. I am going to multiply every single term, top and bottom, by that y. That's going to give me 3y to the fourth minus, and these y's cancel out, so I'm left with 36y squared. And then in the denominator, 4x squared y to the third. And that is my second derivative in its simplified form. That was my last example. I know there was a lot of algebra in this video, so please reach out if anything is unclear.